So hello everyone. So alongside with Kenji, I will present you the ALAMOD project. So basically the idea is to go from long-term experiments, data, to gather data, and then to be able to build models based on those data. Basically in France, we can say that we have some kind of diamonds, but not well polished, because we have a lot of data sets, we have a lot of experimental sites, but they are not all put together. And on the other hand, we have also a huge community of model developers, and those community of model developers, they do not take advantage that much of the data that we are producing. So the idea is really to try to put together all this data, put them in a common format, and then be able to share this with the experimentalists, with the models, sorry. Basically, this is how the project is organized. So we have a first work package on the data production and distribution. Then there is a second work package where we work on gathering those information, create databases. There is a third work package on data interoperability. There is the fourth work package that will do like model intercomparison. So the idea here in that work package is to more work on the model themselves, but not developing them. And then we hope that we can learn a lot from that, and we have nice ways to develop new models. And now we'll give the floor to Kenji for the highlights.
Thank you, Bertrand. So yeah, I'm gonna show you an illustration of how we applied this general framework for the evaluation of soil carbon models, which is a part of the project. So we start by gathering soil carbon data and required variables for soil carbon modeling from long-term experiments. So to date, we have a data set of about 30 long-term experiments in temperate croplands, mainly in France. So we have collected for these experiments daily weather data, soil characteristics, of course the soil carbon stocks evolution in topsoil. And we also have calculated carbon inputs using crop yields, harvest index, and organic fertilization. And we also collect some site metadata like past land use history, localization, or type of experiment. And once we have this dataset organized into flat CSV files, the second step is to make this data interoperable. So this is done by semantic modeling of the variables using the OBOE ontology. So now the dataset is organized into a graph database with shared ANA-EE standards, which will allow future interoperability with other datasets. And as an output of this pipeline, the dataset can be queried, filtered, and exported alongside with metadata into either open data repositories, but also this dataset can be used for carbon modeling. And this is the last part of this work, the model calibration and evaluation, thanks to this observed data. Currently, this work involves an ensemble multi-modeling with 6 models like ROTC, Century, ICBM, AMG. So this work has just begun, but I can say that the use of multi-ensemble modeling will allow to assess and reduce uncertainties in soil carbon models. So thank you.